we are doing the thing where I study on stream and I don't really talk to you very spooky soon. Hi Sabina. Hi Sabina. I hope you're doing well. Yeah, we're doing a thing, chat, where I'm just gonna study and you're gonna either be here or you're not gonna be here, and that's the whole stream. So if that's not what you want, I understand. This isn't content. This is not content. This is just studying. So, I mean, there's nothing else to intro. I can't hear it all. Can't hear you at all. I'm in school. Well, I am not in school. I'm at home presently. I have another class in several hours. I'm just gonna study until I have that class. That's what's happening. So we're doing neuroscience and then maybe not neuroscience, depending on how this goes. So I understand there's no audio, music. Give me a second. That is so loud for me. You are gonna have to, oh wait. Okay, we're gonna start back at the beginning. We're just gonna listen to Animal Crossing. Lunch be crazy out here, yeah. Okay, from this point on, I'm just gonna study, and you're either gonna watch or you're not. And I'm not gonna pay very much attention to you, because I actually genuinely need to get all of these practice questions done before this class. And there's like, I don't know, like I have about 50 pages to do. So let's just, reticular theory. All I'm gonna hit this mic so many times. Okay. All cells are connected. Share cytoplasm. Oh, I don't fucking remember who did what. Santiago R something? And then the other guy, I don't remember. This one is neurons are cells. Oh, I should put a title on the stream, actually. Smile. Okay. TGS is still on smile, and that's still the subgoal. That's fine. We can deal with that. Also, I understand that that's OChem. We're all just gonna have to deal with that. The fact that also I have OChem that I need to do eventually. That's fine. Neurons are cells. T. I don't know. Not all connected. I literally didn't retake notes on this part because I was like, I know it, but maybe I don't. I also don't know that this is the guy's name. This is gonna be great. I'm gonna do so well. I did not realize you could not hear the music. I'm sorry. Okay, and then Schwann cells are just shitty little PNS. And one axon. One location. Sag. We'll write it in green or something. Put in blue. Sag. I think I'm hilarious. Who is correct? The correct one. I think it was like Santiago or something, but I could just be like lying to all of us in cold blood, which would not be a surprise. Oh, I forgot. I want this muted, but I did set up Subway Surfers. So chat, you can watch Subway Surfers if you want. There we go. That way you can have Subway Surfers chat. Match the glial cell with the type of function. Well, I don't think you gave me a matching box. So, myelinate. This is a fun game. Count how many times I accidentally stabbed this mic with my pen. Microglia, om nom. AK. They take out bad things. I don't know. They turn into like an amoeba-like thing and they go om nom nom to all the stuff that's bad. Astrocytes support the blood-brain barrier, which is called the BBB. They also myelin 8. I spelled that wrong, but worse. Draw prototypical. Oh, T, I know this. This is the soma chat, and it has a few spiky bits, but mostly it really doesn't. This is my axon chat, and you're not allowed to make fun of me for it. And this is the axon, or so this is the whole neuron. That's the axon, and this is the terminal, and the terminal goes there. And then this is like a big spiky part, and then off the big spiky part, all the dendrocytes come off. And they all come out, and they all go, wow. That's a lot of damage. I don't know. 6 exams tomorrow. Okay. This is the soma. The soma integrates? What are my options? Input, dendrites. Do input. Then oh, this is propagation. Propagation output. Right, because we don't know a lot about integration. This is the axon. This is the terminal. And that means the soma does integration. That tracks. And this is the axon helic, which is important because that's where threshold is. Oh, I should give you guys chat. What the hell am I doing? Wait, chat's supposed to be on this. Oh, because this needs to go behind. What? Where is chat and why is it not here? I don't know. Wait. Is chat just broken right now? Is SE Live just broken? I don't know. Whatever, no chat today. I don't have time for this. I don't know, chat is supposed to be here, but I'm guessing that SE Live is breaking, so I could fix it. Let's go on a 3-minute try and fix it adventure, chat. It's not even gonna be 3 minutes. It's gonna be a 45-second, can I fix this problem before I decide I don't care anymore. Overlays, chat. I want to use it. Yeah. Copy overlay URL, please. Please. Properties? I don't know. Okay, well, chat is just broken, which is fine. We're all just gonna not talk about it, and then it's not a problem. I don't know why it's broken. I didn't do anything. Okay. Okay, well, there's one more thing that... Oh, I turned my iPad off. That's my lock screen. We'll do baby chat, and we'll do... Okay, hold on. There's another way I can fix this. Pop out. Literally, what the hell? Okay, well... Oh. There, now you're on the screen. It's just not as good as you normally look, but it's fine. You're still beautiful. It's fine. I can't be bothered. There. Now I can stop messing with it. It's That was my notification, not your notification. And I have to respond to this notification. Busy, okay. The alerts aren't working. Something's wrong with SE Live. Thank you for the donation. I did not break TTS. I'm checking chat just because I can see the activity feed. I did not break TTS. Something is wrong with SE Live, and that's why chat is broken and the overlays are broken. It's not my fault. But I will take off the thing that says TTS is on, because it is not. TTS is not on. Thank you for the donation. I really appreciate it. Let me read your message. Bryn, I don't appreciate the oppression. This is low, even for you. I can't read the paper. Make us smaller. You don't, no, I'm not using that textbook right now. It's just there because I will eventually need to use the textbook. I could make myself bigger, theoretically. There. Now it's like the textbook isn't even there. I'm fine. Okay. Look at me. I'm so studying. I did that. Next thing is a CT scan. And how is it described? The condition can either be named or described. Oh. I believe this is hydrocephalus. I don't know how to spell it. Cephalus? I don't know. Something's hydro something. Treated with a shunt. And it is caused by too much, like, oh, I got another Discord thing I was picking up. Sounds good. Thanks. Okay, cool. Caused by too much fluid, cerebrospinal fluid in the brain. Okay. And it just compresses the brain, which is why there's the really big ventricles. I know things. I am so good at what I do. Capillaries in the brain, the BBB, which is the blood-brain barrier, stops many molecules from entering. And that is between the endothelial cells and the gap junctions. I don't know. It just closes the gap junctions and makes it non-fenestrated, seals gap junctions. The neuron has many of the same structural elements of any other body cell. What cellular element differentiates neurons from the other cells in the body, and how can this be used in identifying neurons in a laboratory setting? Neurofilaments. Neurofilaments stain the protein. Smile. What are the 4 general neuron categories and their purpose? What if I didn't know? What if I just didn't know? What if I don't know? Because I think I don't know. That's the first one where I've been like, ooh, I don't know. What's like... No, I don't know. No, I don't know. It's like there's a short one and there's a sensory one that comes in with the amount of sensory information. It's got a lot of dendrites, which take up the thingy, the inputs. And there's a short one. I don't know. I'd have to check. Which is not the point of this. What is the function of the corpus callosum? What is it made of? What type of neurons? Oh, I was just going to say neurons. Neuron axons. It connects the right and left hemispheres. This is also not normally how I write, but I don't care right now. What type of neurons? I don't know. Highlight. True or false? I love a good true or false. Okay. The number of dendritic branches correlates with the number of inputs. That is true. Well, actually, branches, and it's also spines, I guess. So I'm going to say true, and then I might be false because they're talking about the spines, not the branches. We'll see. Sensory information enters the spinal cord through the dorsal, and motor information leaves through the ventral. True. Gray matter is interior relative to white matter in the spinal cord. Yes, that is true. Gray matter is exterior. Yes, that's true. The meninges only encase the brain and not the spinal cord. This is also true. There are no regions of the brain that lack the BBB. False. There are parts, and that is why alcohol affects the brain. Afferent, which is... Afferent is entering and efferent is leaving, I think. The brain. When I talk about leaving and entering, it's the brain. It's the brain. We're talking about the brain. The whole thing's the brain. This whole class is the goddamn brain. That's my whole major. Whether it's part of the somatic or autonomic. Autonomic is smooth muscle, and somatic is not. It's just what you consciously control versus unconsciously. So like your heart beating is an example of the autonomic nervous system, because it's still got to tell the brain or the heart to beat. It's just you don't got to sit there and think about it. Nerve carrying information from your eyes to your brain. Oh, fuck me. From your eyes to your brain. It's not really, well, it's afferent, so I'm just going to put an A. And that's, I'm guessing it's also autonomic. Nerve carrying command to move your arm. That's efferent and somatic. Nerve causing your heart rate to increase is efferent and autonomic. Nerve carrying pain information when you step on a tack. Well, that's afferent and autonomic. I do have the answers to these, by the way. There's like 6 or 7 sets of questions that I'm gonna do. And and this is like the first set. Because she gave us all these questions, and I was like, I'll do them before the exam. And now it is before the exam, and I haven't done them, so that's not great. Layer 4 is input. Layer 5 is output. So which layer would you expect to be thickest in the visual? It would be the 4. It's putting a lot more in than it is. Wait. There's a lot more input than... I don't know. Motor cortex, there's a lot more output, so 5. Why? I don't want to write that down, but it's just because that's their job. Is this the last? No, it's literally not. Oh God, Jesus, God Christ. Oh, but it gives me them this time. Wait, it didn't give me them the last time, did it? No, it didn't. Okay, well that's good. I like that. I like that. Okay, let's read through the things. The hippocampus, the amygdala, which is like, I'm gonna write down my own thoughts in gray, and then I'll write down the actual answer I have on the other side of it in black or whatever. So the amygdala is physical changes from emotional states. So like if you're scared, your heart rate increases. I know the hippocampus in my heart, but I don't want to tell you. That's it. Hypothalamus? Oh, fuck me. Frontal lobe is motor. Temporal lobe is language. Memories. The other thing. The parietal. I don't know how to pronounce it. This is my major. Oh my god. Anyways, that's in the middle. It's, this word actually means wall. It's in the middle of all of them. And it does late, sight, and all somatosensory. And somatosensory, the cerebellum is motor, planning, and learning. Motor planning and learning. The occipital lobe is the back, and then it's early sight. The others, I don't remember. Which, I mean, I recall like 50. If I see it here, I'll know. But I don't currently know. Okay. Maintaining your balance and for motor learning is going to be the cerebellum. Cross it off. The cerebellum. Responsible for processing early visual system information is going to be the occipital lobe. Cross the girl off. Cross the boy off. I've been saying, like, the boy this, the boy that, kind of a lot. And I don't know if it's just funny to me, but it is so funny to me. Okay. Formation, consolidation. Ooh, formation of memories? I'm gonna leave that one off for now. Collection of structures involved in emotional processing. I'll leave it off for now. Most human part of the brain allows you to inhibit inappropriate behaviors. Oh. I'm gonna say basal gang? No, surely not. I think it's the hippocampus. I'm fucking myself right now. Oh my god. Smooth voluntary motor control. I know these, I just don't know them. Okay, I know this one. X is gonna be the limbic system. Probably. Coordinate your autonomic response to emotions. It's the amygdala. This is the IX. Where your sense of touch is processed, I don't... Okay, well let's look at these and look and see what's motor. Because I know this is motor planning, and this one's motor planning and learning for sure, right? I don't know. I should know this. This is the part for the record. Okay. For the record, this is the part where I'm both most nervous and most needing to practice. So I know this is my weak point, and I Ben knew this is my weak point, but also this is the time where I kind of need to learn that stuff since the exam's tomorrow. I don't know. We'll see. Inhibit inappropriate behavior. I'm gonna go with hippocampus, and I don't think that's right, but it's what I'm gonna go with. There we go. This also gets a question mark, because I'm pretty sure, but I'm not 100% sure. Formation column, solidation of memories. I'm gonna go with that for the temporal. But I feel like it doesn't fit exactly what I know. I got an email. It was a boring email. Collection of all involved in smooth voluntary motor control. Well, now I think that's the hippocampus. Maybe that's the basal ganglia. I'm gonna go with basal ganglia. VIII. Sure. Hypothalamus. There's still, no, then it's the answers for this set. Here are the three. God, I am not going to do well on this exam. I need to study these after these questions. Collection of structures involved in emotional processing. Emotional processing. I don't know. I just crossed off that one. I don't know. We'll say hypothalamus is IV. This is also a question mark. I don't know a lot of these. Okay, and then the last one is VI. Does that make sense? Auditory information in the temporal lobe absolutely does, or in the frontal lobe absolutely does not make sense. But let's check our answers. Reticular theory was Golgi. Oh, I did know that. Okay, I did know that because he's just a guy. And he came up with Golgi stain. Web-like system, yeah. All neurons are connected in a network. I did know that. Santiago, I was so right for that. I was so real. And I said Santiago something R. And I was so real for that. I do kind of need the title up for the fact that I'm gonna... make it be that instead, since freaking SU Live hates me right now. That's fine. Okay, anyways. Connected. I was so real for saying Santiago something R. I was so right and real for that. Look! Santiago R. I'm a genius. Oh, I started with blue and then immediately transitioned to purple. We don't need to talk about it. Opposes theory, believe there was no continuity between neurons. So true, bestie. Suggesting was made up of discrete individual neurons, cells, the neuron doctrine. I knew that. The fact that they used the stain developed by Golgi to trace individual neurons. Oh, I said the fact that they both won like the same prize for the same thing at the same time, and they spent their speeches arguing with each other. Which was so funny that she told us that. Form the myelin of neurons. True, did know that. Myelinate several parts. Did know that. Several axons. Have several parts of several axons. Central nervous system. Connecting cell body. Separate from the neurons. I don't think I knew that. Oh wait, I did know that. Duh, they're their own thing. Conversely, Schwann cells myelinate a single part, check, of a single island, check. Axon, check. In the peripheral nervous system, check. With its entire cell body. Well, that would make sense since it's only doing one thing. It's fucking lazy. Fucking lazy ass cell. Jesus Christ. Multiple segments and multiple axons. Yeah, I knew that. Brain and spinal cord. I did know that because it's the CNS. T, did you guys know? This is such a silly little... Did you guys know? I could move the camera for you. Did you know that technically your eyes are part of your central nervous system? Isn't that strange and weird? I bet you had no idea. They are. So is your spine. I'm gonna die. Microglia, scavenger cells in the brain, true. To clear debris, I think I knew that. Modulate inflammation and cell survival in the brain. Yeah, I knew that. I'm not just saying, I am not the type of person to go, oh, I knew that. If I see it, I will be like, oh, I didn't know that. But sometimes it's like, I didn't remember that, but I did know it. If that makes sense. Like, Golgi is one of the cases where, like, obviously I knew that, but, like, I didn't remember it. But generally, I think that's not a big deal, just because it's the dude's name. Fuck him, you know? Astrocytes provide structural support. I did not say structural support. I specifically mentioned the blood-brain barrier. Respond to neurotransmitter and contribute to the synapse. That's fucking crazy. I didn't know that. That's fucking crazy. Dude, the brain's so weird, and we just don't know anything about it. But we like, know a lot of things, but, like, not a lot of things. It's weird. It's weird. Okay. Cool. One cell provides one segment of myelin to a single. I knew that, yeah. Input, dendrites, I said that. Propagation, I said that. Integration, soma, I said that. And output, I said that. Yay! But they didn't draw it. My teacher didn't draw it. Oh, yes, she did. Oh, she, like, labeled shit, though. I just labeled those 4 parts. But yeah, the nodes of Ranvier are in between the myelin. That's where the things happen. The myelin's what makes it fast. Everything else I labeled. But not the myelin and the nodes of Ranvier. Hydrocephalus, that's what I said. A buildup of CSF, I also said that. In the ventricles, I didn't specify that, but I felt like it was self-explanatory. This puts an enormous amount of pressure. This happens a lot to cats. Enormous amount of pressure in the brain and skull. It's treated by a shunt system, I said that. Yeah, and then it basically just goes back into your, like, abdominal fluid or whatever. Or it can go to your collarbone, which is crazy. Specialized catheters, yep. Capillaries throughout the body are fenestrated, meaning that they, I believe I specifically did state non-fenestrated, have perforations and pores to allow blood flow between the capillaries and the surrounding tissue or organs. So true. Meaning they have brain capillaries, paradoxically, are non-fenestrated. I said that specifically, actually. Meaning they have tight junctions and highly regulated barriers supported by astrocyte feet. True, I said that. I don't know if I said that, but I mentioned it earlier. Supported by astrocyte feet to only allow specific molecules into the brain via the blood. I did know that, yeah. I don't know that I went that in depth. I'm not writing paragraphs. This is practice questions. I don't need to write paragraphs for that. Neurofilaments, I said that, are the only things present in neurons, can be used for staining techniques. I said that to differentiate neurons from other nearby cells. Maybe I won't fail this. Well, we haven't gotten to the part where it's like the things that okay, well, I might fail it. Okay, this part I didn't know. Motor neurons, interneurons, projection neurons, and sensory neurons. So I'm going to look away now that I know the names of them. Motor neurons are going to do the motor. They're going to move your muscles. T. Interneurons are going to be the ones that are just kind of like passing the signal. Projection neurons send a signal. Interneurons send a signal locally. Projection neurons send a signal not locally, very far away. And what was the other one? Sensory neurons are gonna send something using a different kind of like dendrite system, and then they will send it to the rest of the thingies. I think that's right. Let's see. Muscle contractions or secretions. Didn't know that. Communicate between nearby regions. I said that. Of the CNS, specifically of the CNS. Okay, I didn't mention that. Communicate between distant regions of the CNS. Well, I think it's kind of obvious that it would be the CNS because the PNS, the peripheral nervous system, is like your hands and stuff, and they just have really long axons. Interstate highways in between towns. It's so funny. Sensory neurons transduce signals from the environment into neural signals. I got that. So controlling secretions is the part I didn't know. Corpus callosum to connect the two hemispheres. I said that. It's made of axons of projection neurons. I mean, that tracks. Projection neurons specifically, I didn't know. Oh, I didn't know that I forgot. This one was wrong. They were all right except for this one I was wrong. Meninges encase the spinal cord as well. I did not know that. Oops. Okay, well, it also does the spinal cord then. The other ones I was right. I'm not going over those again. Afferent somatic. I definitely said afferent autonomic. This was right. This was right. What is happening and why is it happening? I don't know. Alright, that was right. Did I say somatic? I think I said autonomic. Wait, let's go back. I said A, E, S, A, E, A, and AA. Okay, so I'm getting the autonomic system fucked up really easily. Because these two are right. These two are not. I messed up both of them and said that they were both autonomic. So why are they not autonomic? From your eyes to your brain. Is it just because there's like changes that you have to consider and so it can't be autonomic? Perhaps? Okay, no. I need to think of this differently. Autonomic is just a smooth muscle. I should not think about it if it's automatic or not. I need to think about it if it's smooth muscle or not. It's not smooth muscle, so it's not. Tapping on a tack is not smooth muscle, so it's not. Okay. Okay, dokie. Okay. Thick layer V. IV. That's what I said. Motor cortex is V. That's what I said. Okay. Now it's the scary ones. I don't even think I got that one right. Wow. Let's remember together, chat. I said V-I-X, V-I-I-I. V-I-X, V-I-I-I. V-I... So this is wrong. I-X, V-I-I. Those two are right. Good job, me. Well, that one can't be right since I used that one already. But what did I say for it? Then, so I said V-I-I-I. I-V, I said, then X, then V-I, then I-I-I. Oh, fuck, I messed this up. So I-V, X, V-I. I-V, X, V-I. I-V is correct. I said X, and V-I is correct. Then I said V-I-I-I, I think. Wait. I hate Roman numerals. I literally don't know what's going on with Roman numerals. Also, yes, I just read chat. I don't know. My brain is... I'm in need of a break, and I'm looking over to watch the Subway Surfers, to be completely honest. Usually I watch a stream while I study, which is very ironic, seeing as this time I'm streaming and studying. But usually, typically, I am watching a stream and studying. V-I. Then I said I-I-I, V-I-I, I-I-I. V-I-I. Wait, that's so many I's. I-I-I. I-I-I. So 3 V-I-I, 1, 2. 3 V-I, 1, 2. 3 wrong V-I. Oh, wait. How did I mess this up so royally? 1, 2 is fine. V-I? I don't remember what it was anymore. Oh my god. Okay. I'm just getting further down into the seat as time goes on. I'm gonna write it on a post-it note. This is atrocious that I have to check my answers like this. I could pull it up on my laptop, but I don't want to do that. Okay. V-I-X, V-I-I-I, I-V-X, V-I, I-I-I, V-I-I, I-I-I. I've written it down onto a post-it note. Here's your proof. It's on a post-it note. Okay. Let me erase my checking and I'm gonna just check it again. So this one's wrong. This one's right. This one's right. This one's wrong. This one's right. Wait, no. This one's wrong. 1, 2, 3, 4. Why would you give me the letters and then Roman numerals? Make one of them numbers, please. A, B, C, D, E, F. I don't think I got any of these right, and I don't know how that's possible. Well, these two are right. I don't think any of the other ones are. That's not great. Well, okay, well, we know what we have to study. Which I kind of already knew I needed to study. I could look at them more than just the letters, but... Okay. Formation of memories is the hippocampus. Wait, duh. Everybody knows that. I was thinking too hard. I'm thinking too hard. I need to think less. Just period. I know amygdala, I know basal ganglia, but I want to re-go over basal ganglia. It was the VIII, which is a collection of all structures involved in smooth, voluntary muscle motor control. People without a functioning basal ganglia have Tourette's or some other kind of like Parkinson's or something, but like I tend to just remember it as Tourette's because the others kind of follow that line. Hypothalamus is X, which is the 4 F's. Is the hypothalamus? Eating and drinking, among other functions, is the biological functions. Okay, well, I misunderstood that one to be the 4 F's. If you don't know what the 4 F's are, our teacher told us, and it was really funny, and I went he, and then I remembered it, but I guess I didn't remember it that well. It's the 4 F's are flee, fight, feed, and so that's what she did. And then I was like, oh, I can probably remember that. Clearly I did not. I want to watch putting both my legs on the ledge. Get further down into the seat. How long until your streamer disappears from view? Turn the mic so that it actually faces me still. Okay. So the hypothalamus has like incentivized actions, eating, or not even incentivized, just like eating, drinking, slept, probably. Limbic system is IV. Limbic system is collection of structures involved in emotional processing is the limbic system. I don't think I remember that one at all. Emotional. Sob. Okay. Frontal lobe. How did I not get any of the lobes? I literally know their purpose so well. Frontal lobe is not the human part of the brain. Oh my god. Oh, but I did know it inhibits, like, weird behaviors. But I did not know it was the human part of the brain. But now I guess I do. It's the frontal lobe. Then the temporal lobe is auditory. Yeah, that tracks. Oh, I did know that, because you have to hear the thing, process the language, store the memories. Okay, this is actually starting to hurt my back sitting like this now, actually. But it was so comfy, but it did hurt my back. I'm not sitting in this chair very properly. Okay. The parietal lobe is where your sense of touch is processed, is the parietal. Yeah, this is somatosensory. Let's play a game called Touch the Brain, chat. This is the part that makes you human and also inhibits inappropriate behaviors. It also has stuff to do with motor processing or planning or whatever. This is somatosensory. Somatosensory is like touch and audio and all the yummy things like that. It also does late stage vision. This does early stage vision in the back, but I think I wrote that down. Early visual, and then this is hearing, language, comprehension, and some memory stuff. Welcome to Touch the Brain. Thank you for touching the brain with me today. Take it out of context, I dare you. And the cerebellum is just maintaining balance and motor learning. Okay, well. Oh. No, these are the questions. It's just that I saw the blue. Okay, now we're back on to questions. Yay! Yay. Okay. Consider a normal neuron with expected concentrations of ions. Draw the direction of only the electrical force, electrostatic pressure, and the direction of only the diffusive force acting on each ion. Direction of diffusive force and direction of the electrical force. Okay. Direction of the diffusive force. This is definitely... Oh. Diffusive is definitely in. Diffusive is definitely out. Nobody cares about chlorine, but I guess technically it wants out. Nobody cares about chlorine. Fuck chlorine. Oh wait, no, this would want out. This would want in. This would want in. I don't remember. Honestly, I don't remember chlorine very well. We didn't talk about it a lot because nobody cares. Resting membrane potential, like what number is it? It's negative 70. It's just like when there's like no net flux charge, no net flux current, that's the resting membrane potential, and it's negative 70. That's it. Three conditions for the neuron to be considered at rest. No, I don't remember specifically what the conditions, so I'm going to make them up. Refractory period got 9. No refractory. No net flux. No action potential. I guess. I don't know. We'll check. Which 4 ions contribute to the resting membrane potential? What is their distribution across the membrane? What is their relative permeabilities? Okay, well, I'm pretty sure it's just this again, but sure. Whatever you want. Na plus Cl minus. Cl minus is outside. So I guess it wants... It's minus? It kind of wants to stay outside. The electrical, it would want to stay outside. But I don't know actually what... I got this mixed up again. I don't... What? I don't know what this is. Dude, chlorine needs to get a fucking life. What is the distribution across the membrane? What is the relative permeabilities? Distribution is that they're distributed. I gotta get lunch soon. I'm hungry. Okay. Cl minus. A? It's not really Ca? What do you want from me? 2 plus? It's not really an ion, but we also have A plus, which is proteins. And then K plus, which is the big guy. Small leak, big leak. Na. Small weak. I feel like I know this just fine. It's just like I can't just regurgitate it. I know it in practice. But not in like regurgitation. Which of these is not true at the resting membrane potential? There are negatively charged proteins inside the neuron. Well, that's not really true. I mean, I guess there could be, but like we only talked about the A plus proteins, and those are positive proteins. I don't think they were negative. I think they were positive. The sodium-potassium pump creates and maintains sodium and potassium concentration gradients. This is true, so it's not untrue. Oh my god, there's 5 options. There's potassium flow through the leak channels. This is true. There's a high concentration of potassium ions inside the cell. True. There's a high concentration of sodium ions inside the cell. This is false. Then the proteins, the A proteins must be negative, and I must be dumb. That's fine. I can deal with that. Pumps is true. It pumps potassium, and it can't pump both of them out. It pumps potassium back in and sodium out, and it makes the resting membrane potential net. It's electrogenic. No, because potassium would be leaking out and sodium would be leaking in. And the potassium, the pump resets that and it brings the potassium back in and the sodium back out. If you put the negative thing outside, the positive thing inside. I got an email. It's not an important email. I'm just gonna go with B. Probably wrong though. At resting membrane potential, opening of the potassium channels will result in. At resting membrane potential, opening of the potassium channels will result in potassium leaving through the neuron, entering the neuron, leaving the neuron. Can't determine from this information. Well, they'd leave. I think. I can't imagine they'd just voluntarily stay. That'd be mighty silly. I don't want to voluntarily stay. I want to leave. In the above situation, if there is ion flow, it will cause the neuron to be more positive, more negative, or no charge in the membrane potential. More positive. Because it's negative, and if you take a positive thing out of the outside and you put it on the out of the inside, you put it. Wait. Oh no. Okay. I don't know. What would happen to the concentration gradient and equilibrium potential of potassium if you were to increase the concentration of the extracellular potassium? Less concentration gradient. And it would be closer to equilibrium. Why is the resting membrane potential closer to the equilibrium potential for potassium than for sodium? Leak channels. There's more open leak channels for potassium than there are for sodium, and so potassium has a bigger draw on the neuron because it's moving more. What happens to the resting membrane potential if you increase the neuron's permeability to sodium? The thing becomes more positive. I Let's check our answers. High concentration outside the cell. Okay, and negatively charged. Okay, well, I was wrong in saying that the proteins were positively charged, which is fine. They're negative. I'm dumb. I just remembered they were A proteins. High concentration outside the cell in the extracellular fluid. K plus and negatively charged proteins are in high concentration inside the cell. Proteins cannot cross. I know they can. At rest, the inside of the cell is negative compared to the outside of the cell. True. So in, out, in, out. Oh, that is not what I wrote at all. I said in, out. This is meant to be in, out. So potassium electrically wants to get in to make it more negative, right? No, to make it more positive. But doesn't potassium want it to be more negative? じゃあどうしてかな? どういう意味? Okay, well, we'll see. Negative 70 MV, I said that. Should be at rest. No net flux, I said that. Exactly, yeah, no net flux. Oh, they only gave one reason. What are the 3 conditions? They gave one condition. They gave one condition. It said give 3. I made some shit up and I was like, no net flux, and then, I don't know. Dude, What are the relative permeabilities? Extremely are concentrated extracellularly. Okay, I said that. Membrane is most permeable to potassium. True that. Moderately to chloride. Okay. Well, chloride just is such a little bitch. Nobody cares about chloride. Nobody cares about chloride. Nobody gives a shit about chloride. Oh my god. Okay. Fuck chloride. Most minimally. Okay, well, other than chloride, which fucking shut up about chloride. 0 permeability. I know that. None to charged proteins. What? Oh, no, I did answer that. I did say E. I did say E. Then I said B, which... Oh, I was so right for that! She's a genius. She's a genius. I'm so smart. And the number 6 is B? What did I say? Number 6? Number 6? I said B! Okay, and I said more positive, which... 6 was potassium ions leaving the neuron, moving towards its equilibrium potential. So true. In the above situation, if there is ion flow, it will cause it to be more negative. Okay, so I said more positive. In the above situation, where potassium ions are leaving, it would be more negative. I think, okay, here's where I fucked myself. There's a little chart in my notes right now of like what each ion wants to be at. And I'm talking about the ions like they're fucking people, and they're not people, and I know this, but just like, think about it, okay? Like, I guess I thought potassium wanted to be more positive, but potassium wants to be more negative. So because potassium wants to be more negative, it would just leave. But because potassium's leaving and potassium's positive, it would have to be positive. That's where I messed up. Increasing extracellular protein would decrease the concentration gradient. There would be less diffusive force, less potentials needed to provide a force equal and opposite. Therefore, the equilibrium potential would be a less negative number. I think I said something like, I think I said more positive, but closer to equilibrium. I don't think that's true. I think that the equilibrium would just be more positive. Okay. Increase. Oh my god. Increasing extracellular potassium would decrease CE. I already read that. Because the cell is so much more permeable to potassium than it is to sodium. Due to more leak channels. That's what I said! And the membrane potential will become more positive, less negative. What did I say? More positive. So I was right. I was right. It was just like the one or two that I didn't really know about. And mostly it was chloride. Fuck. Chloride. Alright, I'm gonna take a little break, get a little snack. I'll be like back in like a few minutes. You guys will live. You couldn't hear me. I'm gonna eat really fast. Yeah, we don't need to watch me do this though, so. I come over here. I'll go over here, I can take a bite, and that's fine. Okay. So, you guys come here often? Is more sauce? It's just like a 3-layered sandwich. It's too big to eat on stream. That's weird. I don't care about eating some things, but like this is just a lot of food that I'm trying to eat very quickly. It's kind of weird. I think I know a lot of things. I don't know that I know how to apply all of those things. After I memorize, I know a good part of it is going to be the parts of the brain. Once I like really memorize those, I'll feel good. We're not there yet. I'm going to go through, I still have like 30 more pages of stuff to go through. After I've gone through all of that, then I'm going to learn the parts of the brain. I do have a class to go to in like 2 hours, so I have to leave before then. But I don't know, we'll see. I'll get through what I can get through on stream, and then the rest of it I'll do tonight. Most days are like this. Most days I get home from my first classes, I have a little bit of a break where I'll study. Not usually stream it, but just study. Then I'll have more classes in the nighttime, and I'll get home from those like 8-ish, and then I'll study some more. And on days where I don't study, I stream. So like Friday nights and sometimes Tuesdays, I'll just stream instead. And then the weekends are just studying. Sometimes I have club stuff, but a lot of the time it's just studying. I don't think most people are this like busy, but I did pick A, a weird major, and B, a good like a weird like side gig. So I don't know, it's just weird. Side gig. Good luck. My friends are also, my roommates are also pooling. So good luck, Lynette. Hope you get who you want. I don't know why chat isn't working. I don't know what's wrong. I can't figure it out. I'm gonna have to reset OBS after this, I think. Sign out, sign back in. That might help. It might not, though. I don't know. It shouldn't matter. Good luck, Lynette. I hope you don't have to spend $100. Mm-hmm. It's just weird because literally nothing changed from yesterday to today. So I don't know why it worked yesterday and not today. And clearly it's not just an issue with the way I have the overlays or whatever, because both the overlays are broken, but my Stream Elements pages look fine. The two overlays I have one for chat and I have one for the alerts, which is so you guys can TTS and like I get sub donos or sub alerts or whatever. I don't know. It's very weird. I literally don't know what happened because I didn't touch it. And like one could argue like, oh, well, when I fucked with the other thing, it wouldn't work on that one, but it should work here, and it's not. I don't know. Good job, Lynette. Good luck. Speed run it the way I speed ran. Sewing that thing before I had to move out. Good luck with your pulls. Holy shit, I'm guessing you did it. Congrats. You got her second pull. Good job. So I will take the remainder of this. I will take the remainder of this $100 that you had allocated for this. Okay. Okay. Chat. No links, so we keep pulling. Gotcha. Okay. Well, I'm probably not really gonna look at chat anymore for the time being. Okay. Why is flow of depolarization starting at the hillock unidirectional? And that is because of the absolute refractory period. And the relative one, but not as much. Oh, my hands are going greasy from that sandwich that I ate. Why is there a period in which the neuron is more hyperpolarized than the rest following the downstroke of the action potential? During which the neuron is more hyperpolarized than the rest following the downstroke of the action potential. More hyperpolarized. Oh, then just the resting. This question's worded real weird, but I think I understand what it's getting at. is because K plus channels, the voltage gated channels, are slow to open and close. Specifically slow to close in this case, but they are both slow to open and slow to close. So the K plus like keeps coming in and out. How does the shape of the action potential change if potassium channels are blocked? That's a weird question. That's a weird question I'm going to ask my friend about. How does the shape... Actually, I don't need to ask my friend. I have the answers. What the hell am I talking about? I'm just going to look at the answers. Duh. I don't know. How does the shape of it change? I'm guessing it just doesn't have that dip. No hyperpolarization. Maybe. Why does an action potential occur when a neuron is depolarized enough to reach threshold? Why does an action potential occur when a neuron is depolarized? Because negative feedback loop and A plus, that was an equal sign, opens more voltage, that's an A, voltage E, Na plus channels. Why do myelinated axons conduct action potentials more rapidly? Saltatory conduction. She probably wants an explanation, but I don't want to give one, and so she's just not gonna get one. Why is the inactivation gate of the voltage-gated sodium channels important? Absolute refractory period. I'm not writing the whole thing again. It's absolute refrac, which allows, which prevents, which allows, which causes unidirectional. That was awful. Unidirectional flow, because otherwise it could technically go backwards, but because you can't start an action potential in the opposite direction, because you have that refractory period, you can't. T-drama, big deal. So crazy. Why is after hyperpolarization important for action potential regeneration? Why would an increase in the extracellular potassium ion concentration be lethal? Okay. Why is there an after polarization? Why is after polarization important? After hyperpolarization important for the action potential regeneration? Why would an increase in extracellular potassium ion be lethal? We talked about this in class, but it's a really weird explanation. And so it's hard to explain very well. Hard to explain. It's just like, if more potassium on outside, hyperpolarization be more hyperpolarized. Or no. If there's less of a gradient the potassium's not going to want to leave as much, and there's going to be very little hyperpolarization. I don't know. Let's just read the answers. Oh, this was the graph thing. Okay. That's weird. During the okay, what did I say? I said absolute refractory period. Absolute refractory period. Sodium cannot enter in the region just behind the action potential, so the self-regenerative depolarization phase of the action potential cannot be reinitiated backwards. I feel like that was self-explanatory. An action potential can propagate in any direction at the site of initiation, but can never reverse direction. Yeah, I know. But that's not I answered the question. After hyperpolarization, what did I say? I said, slow to open, close. Slow to close! They open more slowly, which is why the downstroke occurs after the upstroke. Yeah. Basically what I said. Basically the same thing that I said. Which is good. Since the equilibrium potential of potassium is more negative than the potassium's Since the equilibrium potential of potassium is more negative than the resting membrane potential, the membrane potential will be hyperpolarized more than rest. Oh, yeah. That's fine. Why is it... I'm guessing it's like... Oh, there's just no after hyperpolarization. I feel like I kind of alluded to that. But it's just not as sharp and there's not any hyperpolarization. If you block a portion of these channels, the downstroke will be prolonged and the repolarization will occur much more slowly. There will be little to no after hyperpolarization. This is a different font color. These are different. That's really annoying. That's incredibly annoying. Okay. Why does an action potential occur when a neuron is depolarized enough to reach threshold? Threshold is the membrane voltage at which the opening of voltage-gated sodium ion channels becomes self-regenerative. So that more Na channels, voltage channels, open, and yeah, so it's a negative feedback loop, which is what I said. That's what I said! More sodium opens more sodium, which means more sodium. Yay. Why do myelinated axons conduct action potentials more rapidly? Saltatory conduction. Because action potentials only need to be regenerated at the nodes of Ranvier, which can easily be brought to the threshold due to the presence of a high density of voltage-gated sodium channels. Yeah. Myelin provides a high resistance to the leak of sodium ions across the membrane, so they quickly travel passively from one node of Ranvier to the other to the next, all the way down the axon. Yeah, it's just because they have to do less work, and where they do have to do work, because they didn't do work elsewhere, it's easier to do. That's fine. Okay, this was the one I was really waiting for. AHP, which is after hyperpolarization, allows inactivated sodium channels to open their inactivation gates and become able to be opened again, therefore ready for another action potential cycle. Sure, if the sodium channels remain depolarized, the activation gate would remain closed as the stimulus that triggers it to close remains present. Depolarization. I see. An increase. I see. An increase would remain. An increase in K. It decreases the driving force on potassium because there's less of a concentration gradient, preventing repolarization and therefore preventing the sodium channels from recovering from inactivation, and subsequent action potentials cannot be fired. Okay, basically in baby words, which is for me and not for you. Trust me, you don't need the baby words, I need the baby words. If no hyperpolarization, sodium can't get ready to go again. Sodium channel has a bit of a wind-up period, and that wind-up period has to happen during hyperpolarization. That's when they be getting ready. And so if there's no hyperpolarization, you'll never come down from the peak because there's no potassium coming in to change from depolarization to hyperpolarization, or after hyperpolarization, they just stay at depolarization. They're always inactivated, and then they cannot be tripped again. Sure, I feel like I understand that. Chat, if anybody's here, which I understand if you're not, would you guys like another really fun thing on the screen? We could do another video for you guys. We could do an animal video, I guess. I kind of want an animal video. Let's see. Let's see. Let's go to youtube.com live animal feed. No. I like this one. It says 10 hours of forest animals, videos for pets. I think we count as a pet, chat. So I think this is gonna be great for us. So I will just make sure that's on your screen as well. Found the needle in the bag I was watching. Good thing I didn't shove it straight into the tumble dryer. That would not be good. And I want 10 hours of forest animals. And I want... Yeah, that's fine. There's your forest animals, chat. It's for pets. It's a video for pets. So I think it's gonna be perfect for you, chat. Don't you think so? Don't you think that's gonna be great? I'm gonna pull me up out front. Pull this all the way up top. Neil Chan's gonna love it. Yeah, if only Neil Chan had eyes. I think you're gonna love it, chat. I think it's perfect for you. I picked it specially for you. Specially for you. There we go. Now you get to watch some forest animals for pets, some Subway Surfers, yourself, and then if you really, like, degenerative enough, you can watch me study. But I don't think that's why you're here, to be honest. I think you're here for the Subway Surfers and the forest animals for pets. One of you, you're a tree. I am. A tree has an easier life. Okay. Alright. Explain how each would affect the chemical synapse. Oh, well, I think I can fix that by adding some saturation filters. No, I don't want that. I want effect filters. I want effect filters, and I want color correction. And I want it to be way more contrasty, way bright. Hue shift. Yeah, that's great. Gamma? Oh no. Oh, chat, you're gonna love this. I think that should help. I think that should help you. Like you were saying that it would be better if the Subway Surfers wasn't so bright. Well, don't worry. I'll just make the forest really bright, and then the Subway Surfers and the forest go really well together. I do love it. It's so much nicer to watch, don't you think? Your animals, like, you guys are such pets. I'm sure you love it. I think it's great, and I think I'm not gonna change it. Ever. This edible is fire. No, this isn't edible music. I could make chat also, kind of. I think I could make chat. No, I don't think I actually can. Chroma key the chat. Damn it. Okay. For the following, explain how each would affect the chemical synapse process, decreasing extracellular chemical calcium levels. Extracellular calcium levels. Blocking a sodium channel in the axon terminal. Applying Botox to the synapse. Cuts. Snare. Okay, I'm no longer looking at chat, by the way. In a solution with average calcium channels? Blocking sodium channels. Some of these I feel like have no change, which I don't think is correct. So let's just... Less calcium enters the cell. Would bind less calcium. Okay. I'm gonna write it in purple so I know that I didn't know. Less. Okay, that's not how you spell less. That's also not... I don't like how I'm writing these. My handwriting is diminishing. Less in... Less bind to synaptomin. Less NT out. Blocking sodium channels in the axon terminal. Less CA. 2 plus N. C above, maybe? I don't know. Wouldn't affect the process. Great. I literally looked at that one before and I was like, I don't think this has anything to do with it. And then it turns out I was right. Snare protein would not be able to dock the vesicle at the presynaptic terminal. So true. Little to no neurotransmitter release. Yep, I got that right. No, Depolarizing the axon terminal would no neurotransmitter release, no calcium channel to enter through the voltage. What? Oh, without calcium. Oh, I didn't even see that one. Yikes. So then I think this one is Na. But I think this one, no calcium. None in, none out. It's not the calcium that's going out, it's the neurotransmitter that's going in, but if the calcium can't get in, then the thing can't get out. So no in, no out. Yeah, so no change. Be sure you know the roles of the snare proteins and synaptotagmin in the process of neurotransmitter release. Be able to put the steps of presynaptic events in the proper chronological order. I think I can do that. Electrical is passive flow of currency. I didn't say passive, but it said to mention 2 or 3 or whatever, right? Or did it say the main features and I just ignored that and was like, I'll do 2 of each? I definitely just did 3 and was like, I'm done. Cool. Well, it's passive and versus active or blah, blah, blah. Directly the cytoplasm of one or the other. Electrical current can flow in either direction. It's also positive or negative current. Not required for communication. Action potentials aren't. Additionally, they can pass both positive and negative. That's what I said. They are very fast. I did say that. And are important for fast transmission of current. Synchronized networks of neurons. And communication between glial cells. Chemical synapses communicate through release and binding of chemical neurotransmitters. Chemical synapses have synaptic vesicles. I don't feel like I need to read this. We're just gonna go to the next one. I feel like I got that down. I might have only written 3, but that's because I'm lazy and not because I don't know what it is. And I am the type of person to be honest with myself. If I genuinely don't know what's going on, I will just be honest and be like, I don't know what the fuck's going on. But I do know what the fuck's going on this time. Didn't for the other questions, but I did for that one. So the calcium comes up into the cell, and then into the synaptotagmin, and then the synaptotagmin's like, hey, buddy, snare protein, I know what you want to do. And it's like, I want to release some neurotransmitter, and then it does. But it wouldn't remember to do it if the snare protein, or if the synaptotagmin didn't remind it, so. She's got a little bit of an executive function. It's fine. No, because glutamate can also be used to make GABA. It can be used to make GABA. And so, no, even if there's glutamate, it doesn't mean it's releasing glutamate. Actually, if there is glutamate, if the neuron contains glutamate, it's probably not really releasing glutamate very much, because glutamate is toxic. Yucky, gross. Wait, it literally said... GABAergic neuron does not release glutamate. Yeah, that's the question you just asked the question before. I was just in the question previous to this one. Okay. What prevents GABA from using glutamate as a neurotransmitter? What prevents a glutamate neuron from converting its glutamate into GABA and using it as a neurotransmitter? The enzymes, baby! It's the enzymes, baby, and also the reuptake process, baby. Glutamate, NT, cells use glutamine. What do you mean? I mean they use glutamine. What do metabotropic receptors have in common with botulinum toxin? Whoa, this is a very specific question. G proteins, probably. Everything is G proteins. Everything is G proteins. I'm gonna make your Subway Surfers bigger, chat. Bigger Subway Surfers for you. There you go. Now you can see a little bit better. The Subway Surfers. Which I know is what you came here for. Are you guys still enjoying the squirrels? The forest animals for pets? I hope so. Norepinephrine is added to a bath of a cell culture. Congratulations. An electrode is used to record the change from the membrane potential. An inhibitory postsynaptic potential is measured. What type of receptor did the ligand most likely bind to? Norepinephrine is added to the bath. Well, it's not. Norepinephrine. It's the ligand most likely bind. Oh, I don't know. Well, why did the whole stream die when I clicked away? Encoding overload? Turn down the video settings? No. We like it like this. We like it like this here. How does this receptor cause an IPSP? That's the question, ain't it? Well, GABA I know is ionotropic and inhibitory. However, but it's in a bath of norepinephrine. So it couldn't be a GABA receptor. I think it has to be metabotropic. Adrenergic. It's hyperpolarizing, baby. It's that one. I want coffee. Dopamine does not cross the blood-brain barrier because it is not lipid soluble. If a neuron contains a dysfunctional tyrosine hydroxylase enzyme, how can it be treated to still be able to synthesize norepinephrine? By adding... You'd have to add L-dopa, right? Because it's the only other precursor. T, I think I'm right. The experimenter adds another chemical to the neuron culture in the presence of GDP, a molecule that, when applied intracellularly, prevents the activation of, I've had to know this, for IB, for G protein coupled receptors. A faster IPSP is recorded from the neuron when this channel is added to the extracellular solution. What might this channel be? Molecule that, when applied intracellularly, prevents activation of G protein coupled receptors. Faster IPSP is recorded from the neuron when this channel is added to the extracellular solution. What might this be? I mean, she gotta be like chlorine or K or potassium, right? Chlorine? Chlorine girl, is that you? I think it's gotta be her. Chlorine channel. Bitch. Thing. I don't know. It's the one that I think goes to the chlorine channel. It's not literally chlorine. I'm watching the Subway Surfers, by the way. How many transmembrane segments does the receptor to which this channel binds have all together? Oh, fuck. Wait, that like helps immensely. Prevents activation. Oh, I'm dumb. It's GABA. It's GABA. And the answer is 5. I'm dumb. GABA is ionotropic, which means it doesn't need G proteins. The others, the catecholamines and all them bitches, they are metabotropic and they need the G protein. Yeah. I'm gonna go with that. Yeah. Which of the following is true about glutamine synthesis? Glutamate synthesis. Glutamine! I'm skipping. Glutamate molecules will be used as neurotransmitters enter the certain... wrong. Go away. Synthesized in the cells in... Well, that's not incorrect, I guess. Well, it's kind of incorrect. Wait, no, it's totally true, but it's like... Well, no. It's not really in the cell body. It happens in, like, the terminal, which isn't really the cell body, but it is the cell. I don't know. Whoa! Sorry, camera. I smashed my knee into the table. Oops. Synthesized in the neuron cell's body. False, I think. Glutamine is transported from the cell body along microtubules of axons to the nerve terminal where it is converted to glutamate by glutaminase. It's that one. Glutamate is synthesized in near... False, not synthesized in astrocytes. That's an X. Just a really poorly written one. Glutamate is synthesized at the cell body. False. Okay, it's C. Why does the brand... Yeah, why does the brand, chat? Why does the brand? Why does the brain expend so much energy in the form of ATP and protein synthesis? Because it's toxic. Then we get a smiley face because it's no longer toxic. The figure below. Okay. Shows a pyramidal cell from the cortex. The cell, the neuron, is receiving 5 inputs, which are indicated by the locations on the box labeled 1 to 5. Which of the following combinations of inputs would be most likely to cause the neuron to fire an action potential? I like this question. If 3, 4, and 5 are EPSPs... Oh, that's not what it's asking. EPSP is synapse 1, IPSP at synapse 2, no. Single IPSP, no. Spatial summation of ESPs from 3 and 5. That's pretty good. Single EPSP, no. Because we have the option spatial summation. Temporal oh, nope. It's gonna be the other one. It's gonna be this one. Because the closer they are to this little triangle guy, the closer they are to her, and the more of them there are to her, the EPSPs, not the IPSPs, then you're more likely to get an action potential. Yay! What is the overall effect of synaptic transmission of drugs with the following mechanisms? Blocking acetylcholinesterase. Inhibiting reuptake of dopamine. Blocking postsynaptic serotonin receptors. Presynaptic What is the effect on overall synaptic transmission of drugs with the following... Oh, I have to list them! LOL, I don't want to do that. I don't want to do that. Oh, no. Oh, wait, yes. Dopamine, baby. I'm trying to remember what the heck acetylcholinesterase even does. I'm just gonna say no EPSPs. Sad face. Blocking postsynaptic serotonin. Oh. No, that's ache. That's ache. Ache can't... Then, okay. If there's nothing to break down the acetylcholinesterase or whatever it is, then it just stays there. And that would be very bad and sad. Because then it stays there. And then there's just a lot of it. By the way, chat, I'm giving myself another 25 minutes of streaming this, and then I'm gonna go take a break before I have class again, because I have class until about 8 p.m. today, and so I want to take a little break after this. That's it. I got an email. It was my email and not your email. It was a bad email. It was a boring email. I want an interesting email, a fun one. Also, if all of chat dies every time I click away from the tab, I'm really sorry. It keeps telling me I'm doing too much on OBS, which, like, so true. I am wondering if that's part of the problem with chat. But also I don't know why that would be part of the problem. So, I don't know. We'll see! Yeah. I'm tired. Okay, blocking postsynaptic serotonin receptors. Blocking postsynaptic serotonin receptors. would block the postsynaptic serotonin receptors. No APSP. No graded potential. I got another email, so I'm going to check it now. It was another boring email. Also, I didn't even turn on my ring light for this, in case you're wondering why I've looked dark this whole stream. Like, just like half my face is in the light and half my face out of the light. I just didn't want to. This is a chill stream where I do studying. We might actually, this is the last question thingy. And then we get to not do more question thingies. Blocking presynaptic metatropic receptors. It breaks a lot. We'll just go with no NT release. Because I know it has to do with snare. Which of the following is true? GAD is only expressed in glutamate neurons. Surely not. Glutaminase is a synthetic enzyme expressed in glutamatergic neurons. That's true, I believe. But we'll see. It might not be. Synaptic vesicles in glutamatergic and GABAergic neurons express glutamate transporters. That is incorrect. Glial cells express glutamine transporters. I don't think they do. Perisynaptic nerve terminals are the only component of the synapse that express glutamate receptors. Surely not. Surely not, right? Postsynaptic nerve terminals express glutamate transporters. Postsynaptic nerve terminals express glutamate transporters. That's not true. I'm gonna go with this one. I don't know, though. That was my notification, not your notification. I can check the notification later. I love that it just dies every time I click away. It's like, please give us a break. Poor OBS. My laptop wasn't built for this. How is glutamate removed from the synaptic cleft? An enzyme breaks glutamate in the cleft back into glutamine. No. Glutamate transporters on astrocytes, no. No. Glutamate transporters on the postsynaptic nerve dendrocyte, no. What? No. In the cleft back, it's not really any of these. Actually, I think it is astrocytes, so we'll just go with this. Remove glutamate released from vesicles. Well, I don't like any of these answers. Go with A. What is not true about GABA receptors? Can inhibit. That's true. Are only metabotropic. That's false. Neuropeptides require high levels of activity in neurons to get released. Explain why. Because they feel like it. But actually because dense core. Vesicles. How are propeptides modified? I don't know that we went over this, but if we did, I don't know it. What type of receptors do neuropeptides bind to? Oh no, I don't know this. I don't know this. I don't know. Okay, let's look at the answers. I'm just gonna get back into my, like, laying down phase. I literally don't know where that's coming from. What the fuck? Well, it stopped. PlayStation, guys. I don't know. I guess I was, but I don't know which tab I was listening to it in. I don't know. I literally don't know. I don't know. I'm just gonna stop trying to figure it out. Encoding overload. Well, I don't care. Oh. Oh. Why? Oh. I know why. I messed with the cable too much. Okay. Where is it coming from?
I love this part.
Huh? A Wikipedia page was the answer. A fandom wiki that I was looking at for your guys' fic. What the fuck? Well, a neuron that contains glutamate always use glutamate as its neurotransmitter. No. Glutamate is synthesized in axon terminals from glutamine as a neurotransmitter. Only glutamatergic neurons and not GABAergic will express glutamate transport proteins. Duh. GABA neurons do not have transporters to load glutamate from... I should move this closer. From... Move it from... glutamate into synaptic vesicles. GABAergic neurons do not express glutaminase. So true. The glutamate present in cells from glucose metabolism neurons. But metabolism can be converted to GABA only in neurons that express GAD. GAD into GABA. GAD into GABA. Technical difficulties. I fixed it. I fixed it. I did turn that off. I'm hoping it helps the encoding issues that I'm having. One less thing for it to encode. Because we have to have the squirrel! Because what if we got rid of the squirrel? Nobody would watch anymore. Neko Neil-chan would not watch anymore. Then what would we do? Neko-chan would not want to be here if we didn't have the squirrel. Okay. GAD produces GABA. Okay, I'm back to being focused now that I've fixed technical issues, kind of. What do metabotropic receptors have in common with botulism toxin? Both reduce neurotransmitter release. Well, that's the fucking dumbest thing I've ever heard. 'Cause duh. By interfering with the function of the snare protein. Okay, well, I think I literally said snare protein, so... At me. Oh, I said G proteins, but... Whatever. Whatever. I said metabotropic adrenergic, whatever. I said that one. Oh, what? Why is it breaking? G binds to and causes K channels to open, leading to neural hyperpolarization. Oh, I don't think I answered that question. I don't think I saw it. I'm gonna have to read really carefully on this actual exam. I skipped it. How did I skip it? It's embarrassing at this point. Oh no, I did. I said hyperpolarizing. And then I said C. Neural hyperpolarization. Yay. And I said C, which is correct. And then I said adding L-DOPA. Okay, maybe I do have an idea of what's going on. That would be nice. That would be nice. Surely I know what's happening in this class. Surely so. Prevents, a faster IPSP is recording when the chemical is added. What could it be? What did I say? I said GABA. I said 5. So I think I was totally right. It's GABA. GABA! I hate myself. Okay, 5 subunits. I did not count the number of transmembrane segments. I said 5. The answer's 4. Oh, yikes. I don't know. I don't think it's important. I also don't care. Oh. What did I say for that? What did I answer? I said C. And it was not C. Glutaminase is synthesized at the cell body and transported to nerve terminals, where it acts on glutamine brought up by the synaptic cleft, converting it to glutamate. Yeah. I mean, that tracks. That tracks. Why does the brain expends so much energy in the form of ATP and protein synthesis to remove glutamate from the synapse? It's toxic! I'm so smart. Very important to clear out all of the synapse as efficiently as possible. This causes cell death. Cleared by... and then I drew a little diagram, and I know my diagram's correct. Spatial summation of EPSBs at 3 and 5 is what I answered correct. Oh, it literally wanted increase, increase, decrease. That's not what I did, but that's fine. Okay. Blocking acetylcholerase will increase synaptic transmission of drugs. Wait, these answers don't make sense. What is the effect on overall synaptic transmission of drugs? Oh, of drugs. I did it if drugs are applied. I'm curious how wrong I am. Great. I take back what I said. I maybe don't know what's happening. Blocking acetylcholinesterase will increase the amount of drugs that are transmitted. Inhibiting reuptake of dopamine will increase the overall synaptic transmission of drugs. Blocking serotonin receptors will decrease. Blocking metatropic receptors will increase. I don't know that I understand why. This is the one where I don't think I understand why it's like that. I don't know that it's especially my fault, but, you know, it's fine. There were 2 that were right? What a pain in the ass. It did not select all that. It did not say select all that apply. How am I meant to know that? Only expressed in glutamate neurons, no. Glutaminase is a synthetic enzyme expressed in glutamatergic neurons. I think that's true, obviously. And glial cells express glutamine transporters. Oh, what a pain in my ass that it was select multiple. I might have gone about things differently had I known. How is glutamate removed from the synaptic cleft? Yeah, on astrocytes, I was right. What is not true about GABA receptors? Are only metabotropic. That is true. I said that. Their effect is inhibitory. There are both ionic and metabotropic GABA receptors. GABA B are slower and longer, and GABA A is faster, quicker. Chloride. Wait, didn't I say earlier I was like, it's gonna be the one with the chloride receptor? And I was so right for that. I was so right. Oh my god. I think I know what's happening, kind of. Neuropeptides bind to metabotropic receptors in synaptic vesicles that bud off from the Golgi. Oh, we definitely didn't talk about this. The propeptides are broken down into the final peptides that can be used as neurotransmitters. I don't remember having this conversation with this teacher. Explain why large dense core vesicles rely on higher levels of calcium. I think I just said dense core, but it's the same effect. It's the same effect. Oh, I don't want to put those people's names out on the internet. Sorry to those people. I don't know why you'd put your names on a PowerPoint that the teacher's going to post onto Canvas. That seems like a you problem. Oh my gosh, describe processes out loud. Chat, that's you. You get to hear the processes out loud. Golgi did this Golgi staining, the reticular theory. Santiago Ramon e Cajal. Probably not pronounced like that. Said neuron doctrine, teehee, neurons are cells, and they're separate. That's wild. Principle of dynamic polarity. Signals in one direction, except for the electrical ones, which signal in both directions, both positive and negative, and also kind of more really support the reticular theory. It's a little silly, really. The whole thing's a little silly. Ross Harrison, I'm not going to remember these dumbass people's names. Maybe Golgi and Santiago I'll remember, but the other ones, absolutely not. Ross Harrison showed that neural processes grow and extend to other cells, blah, blah, blah. Sanford Play showed synapses via electron microscopy. There are things in your brain, and they are nerves. They are neurons. They send chemical signals to one another, but actually it's electrical changed chemical changed back to electrical, which is fucking crazy. Neuron projections between brain regions are the central nervous system is the brain, the spinal cord, the eyes. The peripheral nervous system is everything else. Interneurons are only found in CNS, which tracks because they're kind of short, they're kind of local. They're neither sensory nor motory. They just like to have a little combo sometimes. Sometimes they just like a good chat with their chat. You know what I mean? Astrocytes are in CNS because they maintain the blood-brain barrier. Oligodendrocytes are only in CNS. Glial cells are only in CNS, or microglia are only in CNS, but then the Schwann cells are the PNS. And there's the glial cells. They all generally kind of help with support, I think. Yeah. Oh, I don't remember the order that this has to happen in. It goes from the something produces it, and then it leaks into the ventricles, and the ventricles push it out through the cornea, I think, maybe not, to the meninges for the CSF, which is the cerebral spinal fluid. Oh, this is the part that I'm bad at. You have to remember the central sulcus, the lateral fissure, the longitudinal fissure, other things that aren't listed right there. Basal ganglia. That is what lets us move smoothly. That's the basal ganglia. The limbic system is emotional. Oh. The limbic system is emotional. Such drama. We just did a lot of this. Threshold is where if you hit threshold, then the sodium's gonna come in, and more sodium come in, and open more sodium channels, and then more sodium can come in. And so the sodium come in, the sodium stop coming in eventually. It's like, that's enough. And the potassium channels open, they're like, hey guys, sorry it took me so long to get to the party. I'm here now though. And then sodium's like, well, they just got to the party, I'm done. And they start inactivating. And eventually, the potassium is still influxing, kind of slowly, but influxing nonetheless. And the sodium's not really, the potassium's effluxing. It's going out. But slowly, and also not really. But also kind of. And then, drama appears. The sodium channels have inactivated. They're no longer moving. And the sodium's just like vibing. And the potassium is still not closed. They're like, wait, what do you mean the party's over? I just got here. And then eventually we go past threshold, past membrane resting potential, go down into hyperpolarization. After hyperpolarization, that kind of area, which is it's after hyperpolarization. And that is the lowest, and then we go back up to resting. In the downstroke type beat time, that is when absolute refractory period happens, chat. When absolute refractory period happens, you can't fire another action potential. But in after hyperpolarization, you can, because it's the relative refractory period. It's just a lot harder to do because you're further from threshold. I don't know what a lot of this means. Membrane potential at axon helic. It's highlighted here. Okay. Neurotransmitters. Ache. Chat and ache. Acetyl-CoA and choline plus the chat enzyme. Literally, it's chat. It's you guys. Makes acetylcholinesterase or acetylcholine, whatever it is, not the ACE one. Then ache, which is something ACE, breaks it back down into its precursors again. Crazy. Okay. This is the last one, chat. I'm not really even looking at them. I'll look at them on my own time. Diffuse modulatory systems are diffuse and they modulate, meaning they deal with like emotional states. Diffuse as in the fact that they start at one place and then spread out. I feel like I've done the thing. So chat, how do you feel today? How do you feel about our exam that we're gonna have together, that you're also taking? You feel good? You feel bad? You feel nervous? You feel excited? You've been good, good, good. Not too bad. Knitting up a sweater right now. Yum, yum, yum sweater. My brain is broken. My brain is broken. Chat. Yeah. I have a class in, it's under an hour. I'm gonna lay down for a little while, and then I'm gonna maybe go buy coffee or something. I don't know. Coffee or something. I don't know. Look at the mic. Chat. I've been enjoying the mic. I haven't seen you in a while, Potatoes, and that's just because I've been streaming at a different time and not that you've abandoned the troops. It's my fault and not yours. I have faith in your ability to ace the test. Yeah, I'm going to put more effort in tonight into studying for it, and then I will probably do well. The thing is with this test, with this teacher, is that if you do well on the 4 midterms, you don't have to take the final. And I would love to not have to take the final. So I'd like to do well on all of the midterms, that I don't have to take the final. That's the dream. That's the dream, chat. But I appreciate your faith in me. I'm gonna see if I can't figure out what the heck's wrong with freaking Stream Elements, that it won't show chat or whatever. Whatever. It's a stick-ass shortcut. Some teachers do stuff like that. Usually you don't get to... So it's basically just you take 5 exams and you get to drop one of them. But they don't usually let you drop the final. But this teacher does let you drop the final, and I'd really like to drop the final. So I'm trying. I'm trying to drop the final. That would be very nice and happy for me. That's it. Yeah. Any questions, comments, concerns before we end stream on this very day? Sorry it was a weird one. Well, I'm not sorry. I put it in the title. I was like, this is what's happening. It's not normal. Boats, hello, and I'm sorry because it's the end of stream. Because I've been studying for 2.5 hours. Well, I did take a lunch break. So I guess I've been studying for like 2 hours. It was probably a 30-minute lunch break. Get some coffee. You sound like you've needed it the whole time. Yeah, well, it's just because my brain is bored of this information. There's only so many times you can be excited about the same basic concepts, and we've passed that time. We've passed the time. Alrighty, chat. Alrighty. I'm gonna see if I can't fix Stream Elements. I don't know what happened. I don't know why it's not working, and I don't love that it's doing that. But I will stream again on Friday. Actually, before I leave, one more thing. Hope you got things done. I kind of did, and I'm gonna get more things done tonight after my class ends at about 8 o'clock. Before I leave, though, would you guys on Friday like to see Link's Awakening? Like, I start playing Link's Awakening. Or would you like to see, like, a shorter, probably karaoke stream? Or we could do something else, I guess, if you guys have a better idea. This is your time to tell me. It'll probably be like a night stream again, because the Friday night is good for streaming right now. But you gotta tell me what you want to see, chat. What do you want to see? I'm not a mind reader. Not a mind reader, unfortunately. Maybe someday. I could be a mind reader. I'm not today, though, so you gotta help me in the meantime. What do you want to see? We could do karaoke. We could do Link's Awakening. Or we could do something that isn't either of those two things. Stupid quizzes, we made in self-promo. Karaoke sounds good. Okay. I like karaoke. We could do, okay, alternatively, we could do like just a mishmash stream. Do some karaoke. I kind of want to make brownies at some point. We could make some brownies, and then we could do your guys' quizzes. Does that sound like a good time? Does that sound like fun? It would be like a little bit similar to the 12-hour stream where we did a bunch of stuff in one stream. Mishmash sounds. Brownies? Oh, well, that's not an answer. Yeah, I have brownie mix. Sounds good? Cool. Okay, well, I have to figure out how I'm going to make that. Okay, and then probably the week after, chat, or at some point we're going to, at some point soon we're going to start Link's Awakening. Which I know you guys don't love the gaming content quite as much, which is totally fine. But I do want to start doing some more gaming content, just because it is nice. It is nice to do. Sounds fun, but there's a high chance I won't be there if it's late. No worries, potatoes, I totally get it. Alright, chat, I'm going to stop rambling to myself, and I'm going to get out of this apartment and over to the building where my class is. Thank you guys for watching. This wasn't content, but thanks for being here anyways. I hope you had a fun time. Sorry I didn't really read chat today. Thank you for donations, for liking the stream, for everything else. After this week, I won't either. No worries. Guys, you're all good. You're all good. Okay. I will see you all soon on Friday. On Friday, for sure. Have a good rest of your day. Can you stream the exam? No.